Right, so we'll take a quick look at this very basic PLC. So this shows you the wiring diagram for it. So we've got at the top, this is our 24 volt supply, pos and neg, protected by a fuse. So we've got each of the inputs here. So as we can see, 24 volts travel down here. When this is operated, so these are your switches on the front of your panel or wherever they may be located, and that will put 24 volts onto this input, and then we'll see in the next video what actually happens with that signal. So in our case, input number one is going to be a normally open push button, so normally open, and it's unenergized state or not pressed. In the case of a push button, no power will pass through it until it's actuated, and then when it's, in fact, the actual sign for a push button is more like that. So when it's pressed down, it will actually make the circuit, and the current will actually travel down here. So in our example we're going to do, input 2 will actually be normally closed. So that push button here, that's a symbol for normally closed. Let's just make it into a push button. So until it's pressed, it will be closed, and then once it's pressed, you press it down, it will actually break that circuit just there. So once it's been pressed, no power will pass and we'll lose that input. So we will later in that video be using I3 as well, which is also normally open. So I2 is the only one we're using normally closed. Why do we use a normally closed for a stop button, you might be asking? Well, at the moment, that has to be closed for the circuit to work. So at the moment, the circuit's allowed to work, and when we press it down, it actually breaks it and stops the process. Now, in the case of a light or something, that's not so critical if we use the normally open input contact to actually send the stop signal. But in the case of machinery, let's say this wire broke here. So at the moment, that would be allowed to run. So let's say this wire broke. Deleted the whole lot now. So that wire's actually come out here. So there's a fault with the stop circuit. It won't allow the process to run because it's just like somebody pressing it. So it's sort of self-monitoring the wiring to the stop circuit. Hope that makes a little bit of sense. Don't get too hung up on it. It will be covered further down the line when we talk about safety, etc. So here are the outputs, pretty self-explanatory really. Each one is a volt-free relay, so we can have each individual output at a different voltage if we want. Nothing more than a switch, so we can be powering on the left hand side, power out with the load on the right hand side of each output, and that is pretty much it. So on the next video we'll attempt a simple program. See you shortly.